Okay, so let's go ahead and calculate CT, and that's pretty easy. We just add these two together. We can make sure we get our units right, and notice this is not 8 microfarads and 10 microfarads. It's 0.008 to 0.010 micro. You got to make sure we get those values right, particularly if we're going to use base units. So 0.008 plus 0.010 equals this. Now this is 0.018 microfarads. So let's write that down, lest we forget it. So, oops. I'm using the wrong color here, so let me do my little whoopsies there, and let's go to yellow, which shows up a little better than black on the blue. 0.018. Let's see, it did not turn out too well, so let's try that again. 8, and that's in microfarads. So that's 0.018 micros. So we've got to have 6 zeros in front of this. So we need to bear that in mind when we're putting that in our calculator. So let's go ahead and do that math. We know that x of c is 1 over 2 pi times frequency times capacitance. So we've got our total capacitance. So let's do the math here now. 2 pi, 6.28, we've covered that a few dozen times, times frequency, which is 10 kilohertz, 10 kilo meaning 1,000, 10,000 times. Alright, so we got to put the first 6, 1, 2, 3, 4, 5, 6. Since this is less than 1 microfarad, be 0.18. So let's see if that's right. So if the decimal place were here, we'd be in microfarads. So 0.018, which is what we have written up there. And we got to move it 1, 2, 3, 4, 5, 6 to get all the way back to the base unit. So that is the right value. Equals, and then we got to reciprocate that. So that is 884 ohms. So X of CT is, excuse me, 884.6 ohms. So now it's just a matter of applying the 10 volts EA divided by 884.6 ohms to get our current. So let's do that. 10 divided by 884.6 equals, and if we move that 1, 2, 3, we get 11.3 milliamps. And there is our answer. So got that one pretty easily. Okay, moving right along, now we're asking for the current through C1 in this guy. So we can do the individual X of C for C1, which is 1 over 2 times pi FC. So let's do that. So let's do 2 times 3.14, which is pi, times F, which is 60, times C1, which is 30 microfarad, 0.023430 equals, remember X. So we have a X of C1 right here that is equivalent to X of C1 is equal to 88.46 ohms. So if we take 100 volts and divide that by 88.46 ohms, I'm sorry for the little tiny ohm symbol, but let's do the math. 100 divided by 88.46 is equal to 1.13. There we go. And that is correct. So just that easy thus far. So let's see what this slide has to say. In an RC parallel circuit, X sub C and R cannot be added directly. So let's blow away this text. It has no relevance to us, even though both values are measured in ohms. So we can't just say, can't just add them. And we can't use this formula that you see down here. So let's see what we've got to do. R and X sub C are not exactly the same quantity. R and X sub C oppose current differently. So this is called impedance. So here is another formula, impedance being Z, the value of this. And look at here, sports fans, is this great or what? So ZT is equal to R total times X of C total over the square root of R total squared plus X of CT squared. So there's your formula to definitely write down. You try to memorize that one and get it right every time. It might take a little while. Not saying you can't, but definitely want to have it written down. So notice the similarities between ZT in series and ZT in parallel. So we do have a relationship. Series, it's the square root of those two squared and added together. And but in parallel, we have the square root of those two added together after they're squared divided into the product of those. So a little bit different formula. Taking the square root of the sum of the squared values accounts for the 90 degrees phase difference here. So they give us this formula. Let's follow it. 30 and 40 ohms. So we got a resistor that's 30 and X of C of 1. That's 40 ohms. So we did 30 times 40 on top, which gave us 1200. We squared 30. We squared 40. 30 squared would be 900. 40 squared would be 1600. Add those two together, we get 2500. Divide 50 into 1200. 50 being the square root of 2500, we get 24 ohms. So quite a mouthful just in one slide. So now we want to determine current. So we just take the voltage, the applied value, which is 100 volts, divided by ZT, which is 24 ohms. That gives us 4.17. So again, that gets us back pretty much to basic Ohm's law. But we got to know how to get there to be able to get to the right answer. So that's why having these formulas and knowing what to do is very, very important. And we can calculate the current in each branch by just simply dividing by either the R or the X of C. And when we take a look, notice these two current values do not add up to I total. Remember, they're 90 degrees different, so we're going to have two values that when summed will add together to be greater than the current value. So taking a look there, E of A divided by R gives us 3.33 amps. E of A being 100 volts divided by 30 gives us 3.33. E of A divided by X of C being 40 would give us 2.5. And so we see those two formulas applied right there. But if we add them together, we get 5.83 when really the actual current total is 4.17. So guess what? I smell another formula brewing. And here it is. We can take the square root of the resistance current, the square of the resistive current, the square of the capacitive current, get the square root of that, and then we have total current. So another formula in the books for us. I know you are as excited as I am about that. So we're going to take a look at this problem here, and we're going to solve it step by step to get these values here. So the very first thing, total capacitance. So if we add 0.33 and 0.27, we're going to get 0.6 microfarads. To get X of CT, we've got to take and do the 2 pi FC into 1 to get that. So let's do that. Let's say 2 times pi, 3.14, times frequency, which is 100, and that is hertz, times, and this is 0.60 microfarads. So 0.12345 and then 6. So here's 0.6 micros, 1, 2, 3, 4, 5, 6. So that is 0.6. Divide that into that, and we get 2653 ohms, or 2.653. Let's see what they came up with. Yep, 2.65 k ohms. So we got that. So now our total, that's easy. Add them together. 1 plus 1.6, 2.6 all day long. So we got that. So jump the slide. Hopefully you didn't peek. But let's do ZT. And this is that big, complicated formula. It's not really that complex. It's just large in size. So let's apply that formula. So our total, which is 2.6 K times X of CT, the total, which is 2.65. Okay. And then we got to put that over the square root of both of those squared. So 2.6 squared plus 2.65 squared, and those are both K. Alright, K. But we're staying with K, so all these K's will cancel one another out anyway. So let's do that math, and I know that's heavily involved. Let's do the top first. 2.6 times 2.65 equals. So the top comes out to be 6.89. And so if I write right here, 6.89. Now I say all these K's are going to cancel out, so we're just going to stick with base units. This is where it gets fun, boys and girls. 2.6 squared plus 2.65 squared, and actually I'm going to change to a scientific calculator so we can do this. So we're going to open parentheses and we're going to say 2.6 and square it, close parentheses, plus 2.6, open parentheses, 2.65, square it, close parentheses, and we're going to add those two. And then we're going to take the square root of that. 3.71 is what I got. So let's see if I did that right, or if somewhere in trying to do all that I goofed up. We'll see. 71. Which means ZT. Let's try that one more time just to make sure I did not mess up. So 2.6 squared is 6.76. So I'm going to write down here, right, 6. I think I did mess up, but let's see, 6.76. And then I'm going to say 2.65 and squared. So that's going to be plus 7.02, so 225, let's say. So I'm just going to come over here and add plus 6.76. I'm going to get the square root of that. Nope, 3.71. So let's do this math. 6.89, I just double checked myself because I was kind of doubting. Divided by 3.71 equals 1.857. So let's see if that's what they got. Yep, if we move all the rhetoric, they got 1.86, which rounds out to what we had. So, very good. So we have stayed right with them through all this. Now, I total is equal